Be glad if you come early. Good
Ma'am,
morning,
I'm
all of
sorry,
you.
but
It's okay.
yes,
So
ma'am.
I will talk to you later.
Today I slept at 11:30 just
No,
because of
that's what I said.
exam.
Yeah, I can understand. I will talk to
Right.
you later.
Yeah, ma'am.
Okay, thank you. Good morning, all of you.
Good morning, ma'am.
So we start with some more slides on kinetic energy. We did a numerical based on kinetic energy. I think you have understood fully regarding how to use half mv square, how to put the values and get the solution. We are going to do it again in a different manner. Please continue.
Kinetic energy. Kinetic energy is defined as the energy of a body due to its motion. Therefore, every
That
moving
is.
body
Just put a that is.
possesses
Abdul, it is that.
possesses as
Hello. That's I dot E is that is.
that is every moving body possesses kinetic energy. Example: a moving cricket ball possesses kinetic energy.
So that's what we had understood yesterday. That anything which moves will have kinetic energy. What is the formula of kinetic energy, beta? It is equal to half mv square, where m is the mass of the object and v is the velocity of the object. You understood?
Yes.
Hello. Yes. For example, you are playing cricket. So cricket ball is moving. Yes, it has been thrown onto the bat, and then the bat hits the ball. So it is in motion until it gets caught or till it falls on the ground. It is having kinetic energy, which is in the form of motion, whether it is hit by the ball, I mean by the bat, or it's been thrown by the bowler. It is possessing kinetic energy. Yes, please read this.
Every moving part in this engine possesses kinetic energy.
So this is engine. This is a huge engine. You can see all the parts moving. So whatever parts which are moving, obviously everything is interrelated. If one part moves, it will be affecting the other part as well. So everything has to be in motion. You see the machine, you see the train. Train is a complete machine. All the parts are moving, the wheels are moving, isn't it? So it is interconnected. The whole object will start moving. So whatever parts which are moving in an engine is having kinetic energy. Any problem? In short, anything which moves has kinetic energy. Have you understood this much?
Yes.
Yes. So I'm showing you in different format the definition of kinetic energy. Please. So you will revise it like this. So I'm not taking extra session for revision. We are doing revision in the theoretical process itself. You got it? Boys, hello?
Yes, ma'am.
You understand? Okay.
Yes.
Yes, start.
Kinetic energy. The work done on a body that caused the body to be set in motion with some speed v can be expressed as function of the body as final speed v and mass m in independent of type
Independent, beta. Hello?
independent of type of force that acted on the body.
So what is this kinetic energy? This is the work done on a body. When you do certain work on any body, the body starts moving. You agree with me? Yes? The body starts moving. You agree or not?
Yes.
Then I say
Yes.
that the work is done on the body. The body starts moving, that means it is in motion. It will have some speed, for example, let's say v. Yes, and we also know it has got its own mass m. So the force could be any type. It could be XYZ, any type of force you apply. It could be pull, it could be push, whatever it can be. It is kicked, or it is given a low force, it is given a strong force, whatever it could be, the body gets displaced with certain velocity, and that is called as kinetic energy. That means the work is done on the body for it to move with a velocity v, having its mass m. Do you understand?
Yes.
Yes. It's all revision, but nothing. We are nothing doing anything new. This is all revision of kinetic energy. Yes, carry forward.
Kinetic energy. Kinetic energy is a scalar, an energy in motion. The kinetic energy of an object is completely described by magnitude alone. The units are the same as for work. This
That
is
is
joules, joules, J.
joules or J. Yes. So we know it is a scalar quantity because it has got magnitude as well as, sorry, it has only got magnitude. There's no direction. This is the energy which is always in motion. This is done by magnitude alone. That's why it is got scalar. And units are joules. That's the same as that for work. So work and energy is the same over here. See here kinetic energy. What is it? Half mv square, where m is the mass and v is the speed, that is in meter per second, and mass is in kg. So kilogram meter per second, that becomes joules. Now we are going to relate the formula for kinetic energy. Please start.
Formula of kinetic energy. Suppose a body of mass m moving with a velocity u is acted upon by a force F for time t. Let v be the final velocity and s be the displacement of the body at the end of the time. The work done by the force is displacing the body is given by work done is equal to force into displacement.
This much
V
you
is
know.
equal.
Work
Yes,
done
ma'am.
is equal to force into displacement. This formula are you aware of?
Yes, ma'am.
Yes. Earlier we had done this. Work done is equal to force into displacement. Okay.
Yes.
Then
V is equal to F into S is equal to MA into S is equal to M into bracket AS.
then
We know that V square is equal to U square plus 2AS, or AS is equal to half V square minus U square. Substi- uh, subs- Substituting for AS in W is equal to M into half V square minus U square. W is equal to half M V square minus U square. The work done is possessed by the body in the form of kinetic energy. Therefore, Ke is equal to half m v square minus u square. If the body is initially at rest and its final velocity is v, then Ke is equal to half mv square.
thank you. Now how to solve this formula? Are you aware of work done is equal to force into displacement? Ninth standard?
Yes.
Yes? Okay, fine. You all know work done is equal to force into displacement. Now, this is the formula, force into displacement. But we know F is equal to mass into acceleration. Remember when we did the Newton's force of laws of motion? Remember? We did F is equal to ma. Do you remember or not? Boys? Hello?
Yes.
Yes, do you remember F is equal to ma? So
Yes.
instead of F, we have put ma and S is brought down as it is. This ma into S can also be written as CMAS. Either I can take these two together or I can take AS together. So what we did right now, we took AS together. So M A into S, we took these two together and kept MA out as AS. This much have you understood? Yes, boys? Hello? Have you understood this much? Boys, can you hear me?
Yes, ma'am.
Yes? Okay. Now, there's another formula of the motion which says V square is equal to U square plus 2S. All of you are aware of it? Yes? V square is equal to U square plus 2S. Now, how to? We can put it as U square plus 2as is equal to v square, right? So 2as is equal to v square minus u square. Got it? So what will be as beta? Is equal to half v square minus u square, and this is what you got. Any problem? I just showed you how we came
No.
to the conclusion. You have all of you understood how we got this formula?
Yes.
Yes, all of you? Not one and twos. Whoever present, I'm asking all of you. Have you understood
Yes.
this much? Okay. Now I'm going to put the value of AS in W is equal to M into AS. So what I do? M remains as such. Instead of AS, we have put half V square minus U square, right? So take out half out. W is equal to half. What I will put over here? M V square minus U square. Understood? So this half we have taken it out and place M as it is and then in bracket V square minus U square. Now the possibility is that if the body is at rest, that means U is equal to 0. If the body is at rest, obviously U is equal to 0 and then it starts moving with a certain velocity V. That's the final velocity. Do you understand? So what is going to happen then? When I place U is equal to 0, it becomes W is equal to half M V square minus 0. Agree? Boys, do you agree, beta?
Yes.
Yes. So is equal to half mv square. This is what you get as kinetic energy, which is got the work. Energy is the work. And then the unit is joule. Any problem? Boys, any problem, beta?
No.
This is how we got the formula of kinetic energy as half mv square. We should know how we got this formula. This is how we derive. Okay? So the summary of kinetic energy, let's find out. Please.
Kinetic energy is first directly proportional to the mass of the body, and second directly proportional to the square of velocity of the body. If mass is doubled, k is doubled, and if the
Kinetic
mass
energy.
is halved, k is
Hello.
also halved.
Kinetic
If
energy. You have to do one more.
velocity is doubled, k
Beta, do you hear
increase.
me?
Yes, ma'am.
Are you hearing me? Can you hear me?
Yes, ma'am.
I just stopped you once. I said K is kinetic energy. So you have to pronounce it as kinetic energy. Okay?
Okay,
Not
ma'am.
KE. Okay? Fine. Thank you. Read it again. If mass is doubled,
If mass is doubled, kinetic energy is doubled, and if the mass is halved, kinetic energy is also halved. If velocity is doubled, kinetic energy increase 4 times, and if the mass is halved, kinetic energy reduced to one fourth of its original value.
fine. So what is kinetic energy? It's directly proportional to the mass of the body because we know that kinetic energy is equal to half mv square. So it is directly proportional to mass. Agree? And also directly proportional to the square of velocity. Do you agree or not? So it is directly proportional to mass as well as square of the velocity. Do you agree or not? Hello.
Okay, I agree.
Yeah, agree. Fine. Now if I say I make this mass double, so kinetic energy will also increase. Yes?
Yes.
And if the mass is halved, I make it half, 50%, kinetic energy also will become 50%. Whatever changes we make in mass or velocity, the same thing you will observe in kinetic energy because it is directly related. Okay, fine. Read better.
Kinetic energy is always positive. Why? Mass is always positive. Even if the velocity is negative, square of velocity will be positive. Therefore, kinetic energy is always positive.
So, do you follow it?
Yes,
Understood? Because if at all the velocity is negative, for example, you are applying a brake, the velocity becomes negative, it comes back, it is negative. But we are doing square of velocity. So if it is negative if at all it is negative, if you make it square, it becomes positive. So kinetic energy is always positive. Mass is positive, velocity may be negative, but the square of velocity becomes positive. So totality of kinetic energy is always positive. Okay. Third one
kinetic energy is a scalar quantity.
that we already know. Then
Yes,
last one.
the term speed can be used in place of velocity in the formula for kinetic energy.
You understood now? So instead of at times kinetic energy is equal to half mv square. So we talk about this as velocity. We can take it as speed as well. That is what has been informed. Okay. So you can, if at all in the question the speed is given, you can put it in the place of v. You understand? Do you understand, better? Yes?
Yes.
Okay. Let's start. So it's all we are talking only of kinetic energies. So many slides I've kept. I hope the things are becoming a bit clear to you.
Yes, ma'am.
It is all about kinetic energies because I'm showing pictorially and so many
Yes.
formulae, how to derive the formulae, how to explain about it. So things all at once it will not become easy, but when we keep on repeating, uh, you can digest it. That's what I feel. Okay, beta, let's start.
The kinetic energy of a moving object depends on two things, mass and speed. Kinetic energy is proportional to mass. 1 joule 2 kg 1 meter per second, 2 joule 4 kg 1 meter per second.
You understood now? As
Yes.
you increase the weight of the object. Now, what is this kangaroo? Isn't it? It looks like kangaroo, I think so. So the weight of the kangaroo is 2 kg and the other weight of the other kangaroo is 4 kg. What happens? The kinetic energy is doubled. Have you seen this? In 2 kg it was 1 joule, in 4 kg it became 2 joules. So it became double, yes or no? If you double the mass, the kinetic energy gets doubled, yes or no? It increases. Boys, can you hear me?
Yes.
Have you understood or not?
Yes.
Yes.
Yes. So if the mass increases, the energy also increases. Yes. Start. See better?
Kinetic energy. Mathematically, kinetic energy increases as the square of the speed. If the speed of an object double, its kinetic energy increase 4 times. Mass in constant 1 joule,
Now,
2 kg 1 meters per second, 4 joule, 2 kg, 2 meter per second.
What we did just now? Hello. We have
Yes.
we have squared the speed. We have made it double. 1 meter per second. The weight of the body remains the same. See, we are not touching the mass. It is 2 kg. It is 2 kg. In the last slide, what we did? The mass of the body was changed. Yes or no? Now what we are doing? The speed of the body is changed. So what we did? We doubled the speed of the body. It was 1 meter per second earlier. Now it has become 2 meter per second earlier. What we find? The work done is 4 times. It was 1 joule earlier. You can see this 1 joule earlier. Now it has become 4 joules. Do you understand? Boys, hello.
Yes.
We'll find the kinetic energy. Please read the question. Please read the question. Can anyone? Hello. Can anyone start reading? Hello, what happened? Can any of you start reading better? Hello? Abdul, what happened? Hello?
Yes, ma'am.
Yeah, please start. What happened?
Calculate kinetic energy. A car with a mass of 13
1,000? 1,000?
1300 kg is going straight ahead at a speed of 30 meters 30 meter per second, 67 mph.
Miles per hour. What is it, beta? MPH is
Miles per
miles
hour.
per hour. Okay. So what do we have to find out? The kinetic energy of the
Kinetic energy of the car.
car. See, you can see this is the car.
Yes.
Someone's mic is on. Please check. Thank you. So the mass of the car is 1,300 kg and the speed that it is taking is 30 meter per second. This is known. This is given. Okay? This is your homework. I've not done it. You have to find the values and give it to me tomorrow or in the WhatsApp today itself. Is it clear? Boys, boys, do you hear
Yes.
me? You have to find out the kinetic energy of the car which has the mass of 1,300 kg and the velocity is 30 meter per second. You have to find out the kinetic energy and WhatsApp me. Is it clear? Or let me know by tomorrow. Okay? What you see over here, I will explain this. There are two balls. One is small ball, the red one, it is less heavy, and the bigger ball, which is olive in color, heavy ball. And what we do, we try to put these balls from one height into the bowl of water. Okay? So you can see over here, in this case, when it falls from a height, the splash is less. Can you see this? The splash is less. And when the big ball falls it, the water spills out. The splash is more. Hope you have understood. Yes or no?
Yes.
Now, what we have observed by this activity, you will stop when I ask you to stop, beta. Abdul, when I ask you to stop, you have to stop, beta. Okay? Because I need some explanation. Let's start. What do you find from this activity? The first one. Please start, beta. Yes, start. Abdul, please start reading, beta.
Both the balls had political
Potential.
energy as they rested on the table.
Okay. Now, look over here. Now, we are going to work on another energy. They are at rest. You agree? They're not moving. Yes or no? So, what energy they have? Potential energy. What energy they have, beta? Potential energy. You agree or not? Because they are not moving. So, potential energy is always at rest. This much have you understood?
Yes.
Yes. So, now we are going to work on the second energy, which is called as potential energy. Whenever a body is at rest or not moving, which energy is observed, beta? Potential energy. When the body is moving, which energy is observed? Kinetic energy. This much is clear? Yes? Is this much clear? The difference between the potential energy and the kinetic energy?
Yes.
Second, please continue.
By the wrist setting
Beta,
up
by resting, read properly, please. You will not
by,
use
rest,
article when it is not required.
by resting up on a high table, they also had gravitational energy.
Fine. You agree this? That when they are at certain height, so this ball is pulled down, even this ball is pulled down by which force, beta? Gravity, gravitational force. You agree? That's fine, they are at rest, no doubt about it.
Yes.
They are at rest, but they are at a height. It is being pulled down by the gravitational force. Do you agree with me?
Yes.
Do you agree with me, beta?
Yes.
Now thirds. That's why we are going one by one. So things become easy. Is third, which is the third one, beta? Please
By
read fast.
moving by moving and falling off
Falling.
of the table, moment and what,
Potential.
potential and the gravitational energy change to kinetic energy. Can
Yes.
you just
Yes.
when
Yes.
just guess when which of the balls had more kinetic energy? The big
Which
and
one
heavier ball.
will have the maximum kinetic energy, isn't it? So which will have the more kinetic energy because the mass is more. So kinetic energy will be more for the bigger ball as compared to the smaller ball. So when it falls off the table, the gravitational energy plus the potential energy will get converted into or transformed into kinetic energy. You understand? So which will have more kinetic energy? Obviously the ball which has got more mass will have maximum kinetic energy. Any problem? Any problem, Peter?
No.
Yes? Okay. Now let's see the activities of kinetic energy. Now this is swing. A girl is swinging. Can you see this?
Yes.
This is swinging. Now this is in motion. So which energy we are talking about? Kinetic energy. Now you know this, what it is called as? Do you know that? Boomerang sort of. It's a type of boomerang, isn't it? Or what you call it as gulel. In Hindi, we call it gulel, isn't it? So people in the ancient time they would hit the birds, they would hit animals, and then to eat them up, to kill them. So this also is having energy because the stone is going with a high speed when it is released. So this is also a part of kinetic energy. Then you can see over here a boy is on the a skateboard. So it is in motion. Can you see this motion? Yes, it's going down. The motion is going down. So this is kinetic energy. And here you can see cheetah, a cheetah running. So this is also having kinetic energy. Any problem whatsoever? Things are
No.
clear or not regarding kinetic energy? Now we'll do certain calculations of kinetic energy. Let's start. Please start. Please begin, better.
A 500 kilogram car is driving at 15 meters second
Per second.
per second. What is its kinetic energy?
Say,
Solution.
make it fast. Don't be so slow, better.
V is equal to 15 meters second
Per second.
per second. Minute is equal to 500 kg.
Better it is M. Read properly. It is mass. Mass is 500 kilogram. V is velocity is 15 meter per second and mass is 500 kilogram of car. Now what is the formula of kinetic energy? Say, what is the formula of kinetic energy? Half mv square, isn't it? Which becomes half into m is 500 into 15 into 15. Agree? Boys, hello. Do you agree, beta?
Yes.
Yes? Fine. What we will get? You can divide it, you will get 250 into 15 into 15, you get 56250 joules. This much will be the answer. Just plain calculation, nothing else. I think you can, this is sheer maths, and you can do calculation very well, isn't it? The second calculation, read better.
Diam- the,
Determine, determine
determine the kinetic energy of a 625 kg roller coaster car that is moving with a speed of 18.3 meters second.
meter per second. Better don't fault over there. It's meter per second. This is oblique, isn't it, better? Salman? Hello? When you see oblique, it is meter per second, beta. Okay? Okay. So what you will get, beta? Hello? Please continue. Can anyone, beta? Boys? Can anyone continue? Hello? Ninth standard, are you there?
Yes, ma'am.
Yeah, please continue, I said.
Yes. Determine the kinetic energy of a 625 kg roller coaster car that is moving with a speed of 18.3 meter per second.
What is solution? See, what they have done, instead of half mv square, see, you can see mv square, but instead of half, they have put 0.5. Can they write 0.5? This half is taken as 0.5. Can you see this? To make it easy,
Yes, ma'am.
isn't it? Yeah. So what they have done, see, 0.5 remains like that. M is 625 kg. V is 18.3 whole square, isn't it? You understand? That means I
Yes,
have to
ma'am.
multiply 18.38 to 18.3. Agree?
Yes.
Agree? Fine. And when you calculate it, so whenever you write any answer, the first one, that is this one, should have, it could be 2.34, it could be 5.32. It has to be, the decimal has to be after one figure. Remember that. So this is how it has been put. And whatever zeros you get, you can make it as raised to. So the zeros may be 10 raised to power 5 joules. This is how you have to present the answer. You understand now? You cannot write it like this, 1.050000. No, you cannot write like that.
Ma'am,
So
time
what we
over.
did, 10 raised to, yes ma'am, just 1 second. This is 10 raised to 5. So the zeros have, we have condensed the zeros and we made it to exponential form raised to 5. You understand? This is how you have to present the answer. So for any problem, do you find? These are all calculations of kinetic energy. Do you find any problem related to the calculations? Yes, better?
No.
Fine then. I hope you have understood today's session nicely and I pray you will remember it. Have a good day and bye.
Bye.